All right, welcome to section 1.4, part 2. We talked about extreme on last part, but now we're going to talk about average rate of change. So if we want to think of a different, easier way to think about the average rates of change are slopes. And we know how to find slopes from Algebra 1 and Algebra 2, so we're going to talk about a little bit about review from that. All right, so what are we going to learn? We're going to learn how to determine the average rate of change of a function. Okay, and basically that is the speed a function increases or decreases. Okay, or I guess it could stay flat or the same. Okay, that's what the determine average rate of change means. The speed of a function increasing or decreasing, or staying the same or staying flat. Okay, so what does it mean, average rate of change? All right, so what does that mean? It means that if you take any 2 points on your graph and you connect them with a line, and you take the slope of that line, which is this formula right here, which is slope, it's y2 minus y1 over x2 minus x1. These two are very similar. And you find the slope, that will tell you how fast the function's decreasing or increasing. Okay, so this one, starting left to right, from this point to this point, this one is going down, so it's probably decreasing. The slope is probably going to be a negative. Okay, if your slope is positive, you know your function is increasing. And if your slope is 0, so all this information is down here, if your slope is 0, your function is flat or constant. And if your slope is positive, you know your function is increasing. All right. So, and then this line that those 2 points are connected to, okay, so this red line here, that is called the secant line. So the line, when any 2 points on your function, you connect them with the line, that line is called the secant line. All right. So let's do an example of how we figure out average rate of change. All right. So this is the function we're using. Okay. Negative x cubed plus 3x. This is the interval that we're using. So here is our x1 and negative 1 is our x2. And here is our slope function for all of these rates of change problems. All right, so I'm going to put in my line with my minus sign on top. And the first part is you plug at your second x value. So I'm going to color code this. We're going to put our x2 into our function. Okay, so I'm going to put some brackets here. So I'm plugging negative 1 everywhere I see an x. So negative 1 cubed plus 3 times negative 1. Okay, so there's f of x2. x2 is negative 1. Now I'm going to do the other side. This side says f of x1. Our x1 happens to be negative 2. So I'm going to do the same thing. I'm plugging negative 2 in where I see an x. So negative 2 cubed plus 3 times negative 2. I'm going to finish off my line down here. And then on the bottom, it's just x2 minus x1. So my x2 is negative 1 minus my x1, which is negative 2. Okay, and if we do the math correctly, that will give us our average rate of change. All right, so let's do the math. Let's do the green one first. All right, so we have negative 1 cubed, that's negative 1, times negative 1 is positive 1, and then we have 3 times negative 1 is negative 3. 1 take away 3 is negative 2. So the green part is negative 2. Let's do the red now. So I have minus, because of the minus sign in the problem. Let's do the red one now. Negative 2 cubed is negative 8. Negative 8 times negative 1 is positive 8. And then I have 3 times negative 2 is negative 6. So 8 minus 6 is 2, but it's minus 2. Okay? And then let's do the blue on the bottom. Minus is plus. So I have negative 1 plus 2, which is 1. All right, so what does this equal? Let's get rid of some of this purple line. We don't need all that. So this is equal to negative 2 minus 2 is negative 4 over 1, so negative 4. That means our slope is negative 4. Our average rate of speed or average rate of change is 4 units per whatever our unit is. So let's think about this. Our interval was from -2 to -1. So -2, our graph, if I go to -2 and I go to my graph, it's about right here. -1 is here, so I go to my graph. And if I connect those two dots with a line, let's see if I can do this. From left to right, that line is going down. So this should have a negative slope, and it does. So my average rate of change is -4. All right. Let's do one more. So we're using the same equation, but we're going to do a different interval. We're going to do from 0 to 1. All right. So let's call x or 0 my x1. We're going to call my 1 my x2, and then we're going to do our formula. All right. So let's see here. So I'm going to put my line with my minus sign in between. So we're going to plug in my x2 into my function. My x2 is 1. So we're going to plug 1 into our function. So -1 cubed plus 3 times 1. Close my bracket. Now let's do the red one. We're going to plug in x1 into my function, so 0. So -0 cubed plus 3 times 0. Close that. And then on the bottom, we have x2 minus x1, so 1 minus 0. All right, so let's see what the answer to this one is. Let's do the bottom first. 1 minus 0 is 1. Let's do the green one now. So 1 cubed is 1 with a negative in front makes it -1. Plus 3 times 1 is 3. -1 plus 3 is not 3. It is 2. -1 plus 3 is 2. And then let's do this. 0 plus 0 is -0. So 2 take away 0 is 2, or 1 is equal to 2. So my average rate of change is 2. So let's see if that's true. Is it positive? So my interval is from x equals 0 to x equals 1. So x equals 0, my graph is right there. And x equals 1, my graph is right here. So if I draw a line connecting those 2 points as closely as you can see that that line has a positive slope. From left to right, it's going up. So that should be a correct answer. All right. This one we're going to do in class the following day, so you do not need to worry about example 3. If you want to get it over with now, you can. And then you can check your answer when we do it in class, but you do not need to do example 3 right now. All right, so the last example we're going to do is as a story problem. This is actually a physics problem, so let's work on this. It's done the exact same way we just did it. The height of an object that is thrown straight up from a height of 4 feet, so h stands for height, is given by this formula. H of t equals -16t squared plus 30t plus 4, where t is this time in seconds, so t stands for seconds. Find and interpret the average rate of speed of the object from 1.25, so there's our x1, and our x2 is 1.75. So that's what we're going to plug in. And this is actually t1 and t2 for this particular problem. All right, so let's do the problem. So our first thing we have to do is we have to plug in t2 into our function. So bracket -16 t squared, so 1.75 squared plus 30 times 1.75 plus 4. Okay, so that's our left-hand part. I'm going to slide this over so I have a little bit more room. All right, so now what do I have? Now it says minus, so I'm going to do minus. I'm going to do a different color here. Now we're going to plug in T1, which is 1.25 into our formula. So -16 times 1.25 squared plus 30 times 1.25 plus 4. Okay, so I plugged in T1 into my formula. And then at the bottom here, it's T2 take away T1. 1.75 take away 1.25. You can do that in your head. It's 0.5. Okay. So when you do this work, okay, so when you simplify all of these problems, I'm not going to spend the time to do this on the calculator now. When you do all of this green, you should get 7.5 minus, when you do all of this red, you should get 16.5 all over 0.5. So 7.5 take away 16.5 divided by 0.5 is equal to -18. Okay, so that is our average rate of speed. Now, what does this tell us? Okay, the negative tells us our graph is decreasing, and the 18 part tells me that my average rate of speed is 18 feet per second. So our graph is decreasing at a rate of 18 feet per second. Okay, hopefully that makes sense. If you want to, you can graph this. Okay, you can graph this equation, and you could see from x equals 1.25 to x equals 1.75, the graph is going down at a rate of 18 feet per second. Okay, so math can help us a lot in the real world. People who do physics for a living, they use a lot of math, chemists, things like that. So science and math kind of go hand in hand. All right, so that's section 1.4, part 2. I will see you tomorrow.